Thank you very much, David. Okay, right now we're going to step over to the computer up near the stage, and we're going to light the second tower together. You all can watch that, and I'll explain to you what's happening as we do that. Okay, what we have here is a control panel that has access to the control room, which is about a quarter mile away. And you can see Tower 1 right now is lit at about 30%, and Tower 2 is off completely. I'm going to slide the throttle up from Tower 1 up to 80%, and we're just going to warm up Tower 2. I'm going to take the throttle to 10%. And then right now, up here, I'm going to activate the power button. I'll explain to you what happens. Okay? Activate the plant. So this signal goes to the control room, and now what's going to happen, since I'm only at 10%, 600 mirrors from this field here, this quadrant of 6,000 mirrors, are going to begin turning. And they're going to look up exactly where they need to be at this time of day for where the sun is in the sky. It's going to use a precise GPS time code to figure out where the sun is and begin moving those mirrors. They'll gradually start moving onto the tower, and probably in about 45 seconds, that tower will light up and steam will start being produced. Steam is already being produced from Tower 1, and the temperature is going to begin rising on Tower 1. And I'll get a report from the control room on the steam conditions in just a moment. The breakthrough that we came up with is the software to take all those mirrors and automatically move them to the correct position. They're dynamically tracking all day long, and in addition, every mirror is in a slightly different position. Okay, you can see the beginning of the tower lighting up right now as mirrors are moving on. The mirrors have to move from their still position or their cleaning position and get all the sun reflected up to the top of the tower. You can see it begin lighting up right now. In a few moments, I'll check into the control room and find out what temperature and pressure steam conditions we have as well. So this is the process that happens in the morning when we first light up the plant right at sunrise. This normally happens automatically. We delayed the lighting of this tower so you all could witness it. So you can see the sunlight going on. Now what you're seeing, by the way, is only the reflections off the very, very edge of the rim of the receiver. All the rest of the light that's going inside the receiver where it's black is heating up the steam on the blackened pipes. Steam gets heated from receiver 2 and receiver 1, comes down the tower, and gets joined in the middle at a Y connection, runs back to the right to the turbine, which is over on my right. That turbine turns from the steam power, turns a generator, and gets synchronized with the grid and puts electricity into the grid for this whole area. This whole plant, when fully running, powers about 4,000 homes, about 2,000 homes per tower, and we'll be building more and more plants with 2,000 homes per tower all across this valley. I'm going to check in with the control room and find out where we are right now. Joe, could you tell me what the steam conditions are right now?
Bill, we're at 540 pounds, 564 degrees, and coming to full power.
Great, thank you very much. So what happens as this continues running, you heard we're at a little over 500 degrees and 500 psi, 500 pounds per square inch of steam. The steam that is made up there is pressured all the way back to the turbine, and it's that pressure which is turning the turbine. Our full operating conditions are approximately 850 Fahrenheit, 850 psi. So it's warming up right now. It'll be on probably by the end of our session, and then we'll be synchronizing to the grid and putting electricity out that way. So thank you again very much. I have a few closing remarks I'd like to make, and then I hope you can join us all over here for food and drinks. There's many, many people to thank. First, all of the eSolar and Ideal Lab employees who made the whole company, who put this together, and then all of those who worked on the event. I definitely want to thank Stephanie and Allison from Elements and everything they did to make this event great. I really appreciate it. And then Walt, you and your whole team, fantastic, thank you. And then from Ideal Lab and eSolar, Rob and Amy and Tom, Kristen, Vanessa, Stephanie, Kevin, Wayne, Teresa, thank you all for helping us get this together. I want to thank some partners who helped us build the plant. Many, many people helped us build this plant. There are a few in particular I would like to call out. I'd like to thank ABB for helping us make the control system for the power plant. I'd like to thank Victory for helping us make the boilers. I think John Biscup is here. Thank you so much for helping us make the receiver that's up on top of the tower that you just saw light up. And I have another vendor I'd like to thank who came a long way to be here with us today. We've worked with them for many years. They came here from China. Mr. Wang, Mr. Ma, Mr. Wang came here from Art Precision all the way in Shenzhen, and they helped us build all of the components that are in the field, and they've been a great partner and great supplier to us for many years. Thank you very much. There's one other person I'd like to thank, specifically a very prescient investor who believed in us back when we were PowerPoint, before we were making power, like we are today. And I really, really owe a lot of thanks to him for believing in us and helping us get to here. And it's Bandel Corrado from Oak Ventures. Bandel, thank you very much for all your support and for helping us build this company. I'd like to thank Joe Long and all the team who operate the power plant. That was Joe who I was talking to back in the control room. And I really want to thank all of you for coming here today. I know all of you traveled a long way to get here. We really appreciate you being here. We're really excited about where we are. We hope you can help us build a great future together. Thanks very much.